Here is a quick video to show how to use the Sharp EL-531x calculator to enter linear data, find the a and the b that you need for the equation and the r value. So we have a set of simple data here, just 6 points. The x is grams, the y is centimeters. What we have to do first is go into stat mode in the calculator. To do that, I'm pressing the mode button. Then I'm choosing 1 for stat. And then I'm choosing 1 again for line, because this is linear data. Once I'm in linear stat mode, I can start entering my points. The first point has x of 10 and y of 20. And the way I enter that is 10 store 20 m plus. It says data set equals 1, which means I have entered 1 point. I keep doing that. 11 store 22 m plus, 12 store 24 m plus, 11 store 25 m plus, 14 store 27 m plus, and 16 store 28 m plus. Once all the data have been entered, it says data set equals 6. It means I've entered 6 points. That helps me to avoid making a mistake. But now I want my a, b, and r. I am going to get a, b, and r by using the alpha key. The alpha key on this calculator is blue, and if you can see, it's quite small. There is a blue a and a blue b and a blue r above the open bracket, close bracket, and divided by keys. So I am doing alpha open bracket equals, and my a is equal to 9.5658. Which I want to the nearest 10,000th in order to retain enough accuracy to make my answers better. For the b, alpha close bracket equals, b is equal to 1.1974. No, messy. There, 1.1, very messy 974. Okay, we know it's 1.1974. And then the r value, I'm doing alpha divided by equals, and my r is 0.895. I'm going to write it that way, but then I'm rounding it to the nearest hundredth, which means 0.90. Showing 3 decimal places at least on my page is useful in case I get a value that's sort of in a tie for whether it's strong or very strong, etc., in the using the table to qualify the correlation. Now I can create my equation, and in this, when you are using this calculator, any calculator that has this chip, you are writing your equation in the form y equals bx plus a instead of the usual ax plus b, because the a and the b have been reversed in the programming of this chip. So therefore I'm filling this in as y equals 1.1974 x plus 9.5658. And because the question is asking me to plug in 13 grams, which is an x, I am replacing the x of 13. And then I am going to simplify. 1.1974 times 13 equals plus 9.5658 equals. And my answer is going to be 25. It will be centimeters because it's a y. And now I want to talk about how much I trust this answer. The r value is 0.9, so I want to say that that is strong. I want to say that it is positive. I always say this even if it seems obvious. And I am going to justify that by saying 0.85, no, it's not fitting, I'll write it here, 0.85 is less than or equal to the absolute value of r, which is less than 0.95. So I can make my answer better by saying, and I have confidence in this answer. Very messy. I'm going to move this up so we can see it a little better. as the R value is, there, made a mess there. R value is strong. That covers pretty much everything you need to do to fully answer a question like this, ticking off all the boxes that are being required by the course. This has been how to use the Sharp EL-531x calculator to enter some data, linear data, to find the A and the B you need for the equation, and the R value you need to show how much you trust your answer.